Today I'd like to introduce a new function called a logarithmic function. It's a function like all the other functions we've talked about, so it has all the same properties as a function. So for every input, there is exactly one output. It also passes the vertical line test. And we'll see that on the day we get to graphing. So when we write a log function, it'll look like this, like y equals log base 5 of x. But since it's a function, we can write it like this. And I'll explain what all of these things mean. The reason we need to learn how to write log functions or solve log functions is because whenever we have something like this, if we know the principal and we know the rate and we know the time, we can find the amount. But sometimes we want to know if I have $10 that compounds continuously at a certain rate, how much time would it take for my money to double? So this is a case where you're solving for when the exponent is the variable. And we'll see that here in a bit. But first let me explain really how you write a log function. So first of all, b has to be greater than 0, and I'll explain why. Y has to be greater than 0. And b cannot be 1. So here's what a base looks like. Log base b, so the number down here is the base, of some number equals x. This is equivalent to y equals b to the x power. So if you'll remember, we talked about inverse functions. So a log function and an exponent functions are inverse, kind of like adding and subtracting are inverses, multiplying and dividing are inverses, logs and exponents are inverses. So these two are equivalent. And the way that I think about moving this is this is the base, so it becomes the base on the other side, and the x becomes the exponent. So I could have something like log base b of the answer equals the exponent. And I would say that the base to the exponent equals the answer. So here's some examples of how we can rewrite logs. Example 1, log base 2 of 32 equals 5. So this means that 2 to the 5th power equals 32. That's an equivalent statement. What about this one? Log base 5 of 1 equals 0. Here's the equivalent statement. 5 to the 0 power equals 1. That's a true statement. Here's another true statement. Log base 10 of 10 equals 1. So the equivalent to this would be 10 is the base, 1 is the exponent, equals the answer. And that's a true statement. 10 to the 1st power equals 10. Here's another true statement. Log base 10 of 0.1 equals negative 1. 10 to the negative 1 equals 0.1. That's true because this is 1 over 10 and 0.1 is also 1 over 10. So that's a true statement.